Objective, dividing exponents. Vic number 1, when dividing exponents with like bases, keep the base and subtract the exponents. So this is the opposite of multiplication, just like division usually is. And with multiplying exponents, we know we add the exponents. So dividing, we're going to subtract the exponents. So if you have 3 to the 7th power divided by 3 to the 3rd power. So the first one goes on top, so 3 to the 7th power divided by, same as the bar, 3 to the 3rd power. The second one goes on the bottom. 3 to the 7th power means 3 is the base, so it's multiplied by itself 7 times. Here, 3 to the 3rd power means 3 times 3 times 3. 3 times. So what we can do is we can cancel out. So 3 divided by 3 gives us 1. 3 divided by 3, 1. 3 divided by 3, 1. 1 times 1 times 1 is 1. 3 times 3 times 3 times 3. So this is 3 as the base 4 times, 3 to the 4th power. Now you can get the same thing from subtracting the exponents. 3 to the 7th power divided by 3. Keep the base, subtract the exponents. 7 minus 3 gives us 4. Example number 2. A to the 5th power divided by a to the 2nd power. So a to the 5th power comes first, it goes on top. A to the 2nd power comes second, it goes on the bottom. A to the 5th power means a times itself 5 times. A to the 2nd power means a times a. Again, a divided by a is 1. A divided by a is 1. We have left a times a times a. A is the base, and it's 3 times, so a to the 3rd power. Again, using the rule, 5 subtract 2 is 3. Keep the base, subtract the exponents. Example number 3, m to the 9th divided by m to the 9th. So, m to the 9th divided by m to the 9th. Well, we're going to subtract the exponents. M is the base, keep the base, subtract the exponents. 9 minus 9 is 0. Anything to the 0 power is 1. So m to the 0 power is 1. M divided by m to the 9th divided by m to the 9th is just 1. Example number 4. 8 to the 4th power divided by 8 to the 6th power. 8 to the 4th divided by 8 to the 6th is how we can rewrite it. So this means 8 times 8 times 8 times 8, right? 8 4 times. In the bottom, 8 times 8 times 8 times 8 times 8 times 8. There are 6 8s in the bottom. And we can cancel these. So we have 8 divided by 8, 1, 1, 1, and 1. And you notice that 1 times 1 times 1 times 1 is just 1. Make sure you know that there's a 1 placeholder in the top, even though all those 8s are gone. In the bottom we have 8 twice, so 8 to the 2nd power. So you can see using the rule, 8 to the 4th divided by 8 to the 6th means 8 is the base, keep the base, and subtract the exponent. So 4 minus 6 is 8 to the negative 2 power. 4 minus 6 is negative 2. Well, we can't have a negative exponent, so what happens is it comes down to the bottom. So 1 over 8 squared. Example number 5. So now we have variables and coefficients with our exponents. 10 divided by 5 times h to the 3rd divided by h to the 7th. So this is pretty easy to simplify. 10 divided by 5 is 2. And we're going to simplify our exponents. So 3 subtract 7 is negative 4. So keep the base, subtract the exponents. H to the negative 4th power. Now we don't want to have negative exponents in our final answer. So we rewrite this as 1 over h to the positive 4th power. And we can multiply. 2 times 1, 2. H to the 4th is in the bottom, stays in the bottom. Example number 6. All right, so we have A, B, and C, and a coefficient. So I'm going to break up coefficient 4 over 12, the other coefficient, times A squared over A. And now there's no exponent on this A, we know it's to the first, times B. There's no exponent on this B, so we know it's to the first. Remember, whenever you don't see the exponent, it's a 1. Over B to the third, times C to the negative 5th power, over C to the 2nd power. And we're going to simplify. 4 over 12. Now this is a fraction that can be reduced, and it is 1 over 3. Now don't get confused. This is not 12 divided by 4. Okay, this is 4 divided by 12. So when we reduce that, we get 1 divided by 3. A to the 2nd divided by A to the 1st. That means keep the base and subtract the exponents. 2 minus 1 is 1. Now, I don't need to write this 1 because I know that it's implied. Whenever I see just the variable, I know that the exponent is 1. B to the 1st divided by B to the 3rd. So I'm going to keep my base as B, and I'm going to subtract my exponents. 1 minus 3 is negative 2. So I have B to the negative 2 power, and C. C to the negative 5th divided by C to the 2nd. So negative 5 minus 2 is negative 7. Now I don't want my answer to have exponents that are negative. So I need to decide what's going to stay in the top and what's going to stay in the bottom. Now A to the 1st is positive. B to the negative 2. Now to get rid of this negative exponent, I need to move it to the bottom and make it positive. C to the negative 7. Again, this one is going to move to the bottom and become positive. 1 times A is just A, so I can actually erase that 1. And this would be my final answer. Here's some practice problems. Example number 7. R to the 2nd times T to the negative 3, all to the 2nd power, divided by R to the 3rd, T to the 3rd. So we can go ahead and rewrite this. Remember, the first one goes on top, and this is all to the 2nd power. And the second one goes on the bottom. So we need to do our exponents, our power to a power first. So I'm going to say R to the 2nd power, and T to the negative 3 to the 2nd power. The bottom's still the same for now. So we have R to the 2nd to the 2nd. Remember, a power to a power means to multiply. So we have R to the 4th. 2 times 2 gives me the 4. T, negative 3 times 2 is negative 6. And the bottom is still the same. Now I have R to the 4th divided by R to the 3rd. So 4 minus 3 is 1. And it's a positive 1, so the R is going to be in the top. T to the negative 6 divided by T to the negative 3. So this is negative 6 minus 3 more is negative 9. So T to the negative 9. Again, we don't want our answer to have a negative exponent, so we're going to simplify this. R is positive, it stays in the top, but T to the 9th would be in the bottom, right? It's negative 9, so we move it to the denominator. So this would be R times 1 is R, and T to the 9th is in the denominator. This would be our final answer. A lot of steps. Example number 8. So let's go ahead and rewrite it. 2a to the negative 4th, b to the 3rd, all to the 5th power in the top, divided by 4a to the negative 5th, b to the negative 1st, all of this to the 2nd power. Now I just put the first one on top and the second one on the bottom. So all of this is to the power of 5, and all the power of 2. So I know a power to a power means I'm going to multiply. Now on this 2, there's an exponent of 1. So I'm saying 2 is my base, 1 times 5 is 5. A is my base, negative 4 times 5 is negative 20. B is the base, 3 times 5 is 15. And now I'm moving on to the denominator. 4 is to the first power, so 1 times 2 is 2, so 4 to the second. A, negative 5 times 2 is negative 10. B, negative 1 times 2 is negative 2. Now I have some coefficients. 2 to the 5th power is 32. 4 to the 2nd power, here, 4 to the 2nd power is 16. And look at your A's. You have A to the negative 20th and A to the negative 10th. So when dividing like bases, subtract the exponents. Negative 20 minus 10 more would be negative 30. Now I don't want to have negative 30. So I know that I'm going to need to move it to the denominator and make it positive. A to the positive 30. B to the 15th divided by B to the negative 2. I'm sorry. A to the negative 20th divided by A to the negative 10th. This means negative 20, subtract a negative 10. Minus a negative means plus, so that gives us A to the negative 10. And again, we don't want to have a negative exponent, so it would be a positive 10 in the bottom. B to the negative 15th, B to the 15th divided by B to the 2nd. So we don't want to have negative exponents. We're going to subtract 15 minus a negative 2. I'm saying 15 minus negative 2. Minus a negative means plus. So 15 plus 2 gives me 17. So I have B to the positive 17th. 32 divided by 16 is 2. B to the 17th, A to the 10th. Now in your final answer, you're not going to have A's on top and B's on, A's and B's written more than once. You're just going to have each variable represented one time. Example number 9. 3xy all to the 0 power divided by 4x cubed y z to the 6th power, all of that to the 2nd power. So we can rewrite it. Remember, first goes on top, second goes on the bottom. 3xy to the 0 power. Anything to the 0 power is 1. Here we have each of these terms. Remember, a product to a power means each term or variable inside gets the exponent. So 4 to the 1st to the 2nd. So 4 to the 2nd power, because 1 times 2 is 2. X to the 3rd to the 2nd. 3 times 2 is 6. Y to the 1st to the 2nd. 1 times 2 is 2. Z to the 6th to the 2nd. 6 times 2 is 12. And all of that is in the denominator. So I still have the 1 in the top. 4 to the 2nd power is 16. X to the 6th. Y to the 2nd, Z to the 12th, and make sure all of that's in the bottom. There are no negative exponents to deal with, so this is my final answer. All right, the last part, Vic number 2. When a fraction is raised to an exponent, the numerator, that means the top of the fraction, and the denominator, that's the bottom, are both raised to the exponent. So for example, 2/3, this fraction is raised to the 3rd power. The top 2 gets the exponent of 3, and the bottom 3 gets the exponent of 3. 2 to the 3rd power is 8, 3 to the 3rd power is 27. This fraction, 8 over 27, cannot be reduced, so this is my final answer. Example number 11, 4/5 to the negative 2 power. So again, the top and the bottom both get the exponent, 4 to the negative 2 over 5 to the negative 2. But then we have to deal with these negative exponents. So remember, if you have a negative exponent in the numerator, it's going to move to the denominator and become positive. The negative 2 becomes a positive 2. Here I have a negative exponent in the denominator. To make it positive, it moves to the top and becomes positive. So now we can simplify. 5 squared is 25, 4 squared is 16, and 25 over 16 does not reduce. Last example, number 12, a negative 1/4 to the negative third power. Now the negative could be in the top or the bottom. You do this problem the same way. I chose to keep it in the top with the 1. So negative 1 to the third power, and you have to have these parentheses right here because it's saying the 1 is negative, and 4 to the negative third power. So negative 1 to the third power. To get rid of this negative exponent, I move it to the denominator and it becomes positive. And 4 to the negative third power is in the denominator, so it moves to the numerator and becomes positive. 4 to the third power. 4 times 4 times 4 is 64. Negative 1 to the third power. Negative 1 times negative 1 is positive 1. Times another negative 1 is negative 1. A positive divided by a negative is a negative. So 64 divided by negative 1 is negative 64.